Good afternoon. Welcome to the QCIS channel. On this channel, I'm going to give you a daily dose of science, technology, engineering, and math. My name is Leon Jones, and what I'm going to talk to you about today are drainage structures. Now, right here, this is what we would call a culvert. Now, this pad right here with this chicken wire, that's known as riprap. Of course, you can see right down here, this is a drainage structure. Now, focusing all the way at the other end, if I could walk through it, there's pipe at the end and there's an inlet at the end. Now, what I have here, this is called a wing wall. It's a wall on the side, looks just like a wing. It's concrete, it's in good shape. So, when I do an inspection, I go ahead and I take, this is a ruler, and I take measurements. Like, I'm going to show you something right now. I'm going to give you an example of what I'm going to do. Here's my ruler. So, one thing that I do, okay, what if I need to know the height? Okay, I put this ruler down right here and I measure the height. And the height, roughly 38 inches. And then I measure across. Roughly again, 38 inches. Now, when I get the measurements, I'm not going to do it right here. I go ahead and snap pictures. Now, what I'm doing for this structure is giving it a rating. So, this structure is what I call a box culvert. I'm going to say 36 by 36, 36 inch by 36 inch concrete box culvert. Call it a box culvert because it looks just like a box. That's the structure. Now, I'm going to look at the structure and I'm going to say, okay, does this structure need to be replaced? I'm going to say the structure does not, no. The structure, because they're going to end up adding 8 feet for shoulder here. So I'm going to say no. Add 8 inches. It will add 8 feet of concrete box culvert. This is what I'm writing up right here. Then I'm going to give it a rating. NDOT rates them 0 to 10, but we use odd numbers. So my rating, if it's still in place, I'm gonna rate it about a 7 out of 10. Now, why did I give it a 7 out of 10? Because looking up here, this is chipped right here. This needs to be replaced. You see the honeycombing down there in the concrete? That's not good. You see the honeycombing over here? That's not good. Now, when you do an inspection, you must make sure that everything is correct. Now, this blue marker right up here is a delineator. Now, why is it blue? It's blue because it represents water. It's known as a delineator. Now, I'm gonna walk up the hill. Hopefully I don't fall. Just bear with me. All right, I got up the hill. This is that blue delineator. traffic out here. I'm here in Noble, Indiana, and I'm going to walk across the street and show you another drainage structure. Now this drainage structure right here is an inlet. This is for your storm water. You see there's already water going down in it. Now when I inspect this, basically I'm looking at where all the pipe is coming from. Put the phone down. There's a concrete pipe coming out this way. There's another one going back that way, but there's water. Now these things need to be cleaned out, because if they're not cleaned out, they get backed up. Now, what I do with everything here, I make sure when I do this inspection, I take the pictures, and it's very, very, very important that you take the pictures, because you want to see which way the water is flowing. You want to see what kind of structure it is. Now, what I'm getting ready to do is show you a third type of drainage structure, because it's very important. As I walk along the road here, you need ditches along the road so we have that water. Now, this one is a pretty new structure right here. This is what we call a concrete head wall. Now I'm gonna go ahead and measure it out. Now the stone that you see down there too, it's more or less kind of a rip-rap type of stone. Now what I'm gonna do, I'm gonna do the same thing that I did last time. I'm gonna get a measurement. Usually go from inside diameter. Here's the inside diameter to the inside diameter, and it's about 24 inches. So this is what we call a head wall. So I'm going to write on my paper 24-inch RCP. RCP is reinforced concrete pipe. Now, because they're going to put a road in or extend the road, they want to replace the structure. Glazed pipe. Now, what's in front of this pipe? It's this head wall right here. And then down below we got your riprap off of this head. Now, since you all saw the head wall, I'm going to write concrete head wall. Because it is a head wall. And I'm going to look at the structure. With my own eyes, here's the structure. Also look inside the structure. Go see what's inside the structure. And as I look at the structure, it looks pretty good. So, what I'm going to do is rate this structure. I'm going to put my rating on here as a 9. 9 is the highest you can get. NDOT uses odd numbers, 1, 3, 5, 7, and 9. Now, some of the equipment that I use. Basically, this is what I call my folding rule. Now, if I want to know the height of this wall, that's my folding rule. This is very important because you have to take measurements. Here, from all the measurements I've done, and I've done a lot, this is all the data that we need. It tells you everything about each structure. And when you're out here doing an inspection, you want to make sure that everything around here looks good. Now I'm also going around right here is the ditch. Because generally when we deal with roads, watch out, don't want to step in it. The geese have been out here. I'm in a ditch. So what's going to happen about 4 years. They're going to take this road bed. I'm going to let you look at the road bed. And they're going to, the shoulder is probably about 4 feet now. They want to extend it out to another 4 feet. And what they're going to have to do is replace this structure with something brand new. So when we deal with any road building, one of the most important factors you must understand is you got to deal with drainage. Where is that water going to go? And I've shown you 3 structures so far. And the 3 structures will tell you where's the water coming from now. Where's the water coming from and where's the water going? Now something else, to really help you understand water flow here, go back here. This is a little pond. This is a man-made pond. So I'm getting an idea of where's this water coming from? Where's it going? Here's another inlet structure right here. This is the top, but this is the inlet structure. This is what the manhole looks like. Now I'm gonna get a little closer to it, show you there's water inside that manhole. And there's a pipe. There's a pipe. Water's going inside that pipe. That's a corrugated plastic pipe. And this is a man-made pond. But here's the top that goes on top of this structure. Now something else you need to know. You need to know the condition of the structures when you are inspecting structures. Now let me tell you this when it comes to these structures too. You want those structures to be in good condition. Now, I'm looking at these structures because the structures that I just inspected need to know where the water is coming from. Okay, and here's another pipe. This type of pipe, this is called corrugated plastic pipe. Some of the water is going in here, and it's probably flowing down to that inlet structure. And there's another concrete structure right there. Now you see that concrete structure needs to be repaired. Let me show you another structure. This right here, that's corrugated plastic pipe. Again, take my folding rule out. I measure it. I'm gonna say roughly with my experience here, it's probably gonna be about 15 inches. Let me take my rule out. And, oh, it's very windy out here. And I'm gonna make sure I get all my paperwork. Almost lost my paperwork. Gotta have your paperwork out here. But you have a lot of pipes out here. As I jump down in here, there's the pipe. There's what it looks like on the inside. And you can see with this job, just got a little dirty. But that's what you do when you do pipe inspections. It's very important because you always have to ask yourself, when you're out here doing inspection work, where's that water going to go? So, what you've just seen has been some drainage structures. Let me show you another one. There's another drainage structure. It's a manhole. It's for your stormwater. Look at the condition of this concrete, it's cracking. And go over here. Here's another section. It's another manhole. And this is rock. It's like number 2 stone. But that's what you know about drainage structures. They're to help drain the water, particularly after it rains, in the pipes, and then the water goes to either a lake, just like the one you see over there, or a pond, goes into a creek, goes into a river, but it relieves the road of a lot of water. And again, you need storm water and you need sewer water. When we deal with road building, road construction, we must ask, where's the water going to go? That's why when they're building new roads, you see a lot of pipe along the roads. They put that pipe in there so they can continue to work on the drainage structures. Drainage is very important. And what you've seen has been a few drainage structures, and I'll be coming back with more content right here on the QCIS channel. Once again, thank you for listening to the QCIS channel. On this channel, you get a daily dose of science, technology, engineering, and math. And if you're looking for some political and social content, you check out my other channel, the 411 Talk Zone Radio Show channel. On that channel, you're going to learn everything about history. You're going to learn everything about what goes on in the real world. I've been doing a scam series on that. Check that one out. Now, if you can't find the 411 Talk Zone Radio Show channel or the QCIS channel on YouTube, you can check both of those channels out on Twitter. Now, for the QCIS channel, I'll take it one step further. Since it's an educational channel, you can find that channel on my LinkedIn page. And once again, thank you for viewing this content about drainage structures on the QCIS channel. Again, on this channel you get a daily dose of science, technology, engineering, and math. Until next time, my name is Leon Jones. I want you all to have a wonderful and gracious afternoon.